Today we're tackling a project I should have done when setting the first floor joists, but forgot, and we're going to be blocking out for mechanical work to drop through the floor. Later in the video, we'll dive into some three-way switches, 2 more projects closer to inspection time. That poor saw has definitely earned its keep. So we had leftover chunk off of one of the hip beams on this roof, and in total it was about 60 inches, and for what we're doing I needed a 28 and a half and a 27, so that was just right. And the depth of those, the height I guess rather than depth, needed to be 9 1/8, so we shaved off the extra. And it's kind of a cool little piece of wood. I don't know what I'd use it for, but I'll hold on to it for the moment because I'm a squirrel. I've got to get the second one cut here. So let's talk a little bit about the loads involved in this project and what I am doing to make sure that the bracing is sufficient and why I think that such a small brace should be fine while I do this work. So I just pulled the 4 screws that are in this joist that is in the way and that are relevant. And ultimately what I'm going to do is I'm going to sawzall underneath the floor, not from the top down, because I don't want to cut more of the subfloor out than is required in order to, because the beam's going to be further in. It's basically going to line up to like right there, just off of our cut marks for where we were hoping to be able to fit that in there, and couldn't quite fit it. And so got the screws out. Now we can go back down beneath. But for the moment, let me show you what the loads are. So there's a bearing condition at that wall, and that wall is directly stacked over top, and you'll see them downstairs with blocking. So I'm not worried about that wall at all. This wall, there is no bearing condition here. So these are supported on that far wall, and they're basically nailed to, but they're not bearing. This is bearing ever so slightly, but all the weight is actually in this column right here, and that's delivering from above. So any weight that's on this end is just deflection weight, from that weight point coming out to the corner. I would say it's probably pretty negligible. And so, with us working essentially with the floor joist that runs right along here over to the far end, I feel very confident that a minor brace should do the trick. And there is blocking every 4 feet that connects the outside joist and nailed with like 4 or 5 nails into this board. So there's at least 2 more pieces of blocking down there that are, going to hold it relative so it doesn't try and roll. And they're going to also help hold it because they're sitting on the outside sill there. So I'm not worried about more than what we're doing. And let me show you what that blocking or what that support is down there. There's our 2 major pieces of blocking, and those little guys, they're just from me basically patching in. I'd originally planned on running one of the ducts from the box we're about to put up over to here, and then realized I can just push it out through the closet, and that's one less thing I had to try and work with down here, and allowed me to actually put in a smaller box because it dropped us down just that much more. And so, well, not a smaller box, but a smaller duct coming down through the floor, and that was helpful. So we're putting in our 2 cross supports here and here. And so I will cut vertical right there and right there. And I've removed the screws, so I should be able to pull that off. It may fight me a little bit once it's cut, just because it is glued as well as screwed, but hopefully not too much. And then I'll be able to run those 2 boards across, and I should have plenty of bearing support, good condition, at least 1.5 inches, 2 inches on the one part, and then another 1.5 inches more further down. And here's the 2 beams. That's what they are, is sections of beam. And you know, they're 3.5 inch by now 9 1/8. They are absolutely more than sufficient for this task, and they will help provide extra support for the weight of the mechanical room, in particular the HVAC unit that's up above them. So they're an excellent choice for this particular application. And I may run an additional little piece of blocking across here just to make sure that there's plenty of support for that. I don't have to, but I should, I think. And once we're done with this project, then we can bring down that great big box and, you know, basically get it installed, which would be very exciting. So here is the support in question. And it does go up and has a slight angle. I have put in just 1 structural screw into each side to help hold it in place, but it is tight. I hammered that in there, so we shouldn't see that floor joist fall any while we're doing this work. And again, there's the extra supports along that whole space. So we should be in great shape for this project. I'm gonna get started by getting the board cut. I want that out of the way so that we can, you know, get the braces in. And it did indeed come out without any major incident. So next step up, get these guys punched in. All right, first of them is in. Probably hard to see. We'll see how the video boost does. A little gapping on the outside board there, but nice and tight. Haven't put any screws in yet. And pretty much flush. Haven't lost hardly any bounce off of that. All on the top there. And I really had to hammer this thing. You can see the marks on there just to get it to go in, which is a good thing. I pushed this thing out, this joist, a little bit in order to get it all the way through, because I did make it quite tight. Yeah. Oh. Yeah. Come on. Go. Go. Yeah. And here we are. All finished up. I did put a couple of small struck screws in on the sides of each of those 2, and just the big old boys coming in. And one of the things you'll notice that I put them in at an angle, and that's because there's a grain to this board. It's just a big ply. And so I don't want to split that grain. So by taking them in at an angle, I'll catch a lot more of the parts of the beam, and that will really help make sure that it stays good and solid for its entire lifespan. And I did forget one. I gotta put one in there real quick, but you can see there's one that goes up into the beam, again at an angle, and that will help lock it in and keep it on the wall very nicely. So let's just go and stand on that and see if we break anything. Hopefully I'm not that heavy. Let's find out. Looks like we're good. There's not really any more deflection in these than there ever was. These were pretty much max span, these 2 by 10 floor joists in the first floor. In fact, the inspector who had come out here to do the shear wall inspection had made a comment about that. Just how long are these joists? What size are they? Well, those are 2x10s. He was like, they're pushing that to the limit, aren't they? And it was like, I think less than a foot to the max span. So it passed, and they build in extra values. So it's not like I'm worried about it, but you do get a little bit more spring when you have a floor. Even, I could have put it in as a 12-inch on center if I'd really worried me or bothered me. It's plenty stiff. Like it's not genuinely springy, but it is more noticeable compared to some of the other smaller spans where there's no spring at all. Yeah?
This is my fishing spear.
What have you made that out of?
Mostly
That looks very clever.
Wired.
So we have lights up in the attic right now, and they're jumpered in 2 locations because essentially they're master suite and attic lights in the way I wired them. And I'm not doing the master suite right now. It has more windows in that area, and it has 2 bathroom lights that I can use to light up a lot of that area. So with those not being the type of light where I can just install it now and there's very little I have to do when you get to the mudding step to change anything, those are all going to be canless lights, so they have to be cut in and set, and they don't hang very well. But the upstairs, the attic, because for a variety of reasons, mostly the weight of the insulation that was going to be pressing down on the fixtures, and our past experience with LED canless, that they don't like that, and that tends to make them pop down, and the springs, I guess you could say, just don't work as well as they should. So up here though, we have canned lights, and we've got them installed, and I just wanted to walk you through. There are 2 types of 3-way switches that we used up here, and how they work and how they're set up. Okay, so you have power coming in, and this is obviously live because I have light so I can talk, so I ain't gonna touch anything. But you have power coming in, and it's on this side here, and then this is your stairs light here on the bottom. On the left side here, it's the 3-way for the stairway here, and then on the right side, the wire comes in the back there, is the 3-way that is basically this hall, if you will. We may or may not ever make anything other than a hall, in which case we may add a light in here at some point. But for now, it's very possible that this is actually going to become like a little closet if we make that into a bedroom, which we would certainly not do, but maybe an office. And so the switches, the power comes into this box, and on the one of these, the light also leaves this box, and that's the stairs here. So the switch down there, all it is just the switch. Nothing comes out of it, just whatever is looped back to this switch. And on this one, power comes in to this switch, then comes over here with a 3-way, a 12-3 wire, and plus ground. And then this one is what controls the light overhead. So just wanted to walk you through. There are diagrams online, and they show you how to wire them up, but some of the logic behind what you're doing. Essentially, when you are flipping the switch, you are opening or closing a pathway for power to run and complete a circuit up through the lights. Okay, so that's really all there is to what a light switch does. And the only difference between a light switch and a 3-way switch is that you have an additional point where you can turn the light on or off, and therefore you have to be able to send a signal between these 2 switches. Okay, so in this case, you've got your light not attached in here, And so power is coming in, and it's coming into the black screw on this side. And then the neutral is simply jumpered to take it over to the next switch. Okay, so the extra black wire is just a way that I'm pulling power from the first plug here to the next plug. So that's all that I'm doing there. So don't get confused by that. So unlike that one, this one has more going on with it because it is taking the power directly from here up to the lights overhead. And so with this one, I had to use this neutral, and it's not jumpered in the same way, okay? So I had to use that neutral to be a carrier. And so you end up with a little bit of a different circumstance there than you would on the others. And so that's why that's coated black, is because that optionally can be used, unlike on this switch and this switch, as a path for power to run. So you need that wire, and you don't have to supply an additional wire to do it this way. So I don't know if it's clear as mud there, but the reason that you don't have a white wire jumpering in with this little stack of white wires on this is because the light that this is servicing is connected in directly to the power supply. So this wire is supplying the power, and this wire is going up to the light, and they're jumpered in. And so you don't have to have that, and that enables you to use that white wire, which you need in this circumstance. You need that white wire to be able to, or another wire, to be able to run down to that switch and back up again with, sufficient, to be able to complete a circuit with multiple options. Clear as mud? All right, so here's the everything off of the one switch, and then the other switch is just there to help support and to be able to turn on at the bottom. So you have blue is neutral because I don't have a white marker. Black obviously is your power in, and green is your ground. And so you're simply, this is like it's a wire, and it's coming up from this one, and all you're doing there is you're simply taking and jumpering neutral to neutral, and then you're going to take your ground and give it a path to go on a wire that goes to the other switch, as well as to go to that switch on the ground there, and then up to the light. And then the switches, obviously the grounds are connected in, but other than that, it's just ground. You're going to take your red wire and connect it in next to the black wire on both of the light switches. And then your black wire, this is your power, is actually going to run over to the second switch. And then you've got your white wire, and this is a 12-3. And your white wire is gonna be connected in white to white. It's gonna be connected in as a power, so it gets to be labeled with a black tape. But it's in the position by itself, or on my switches, it's not always this way. It's on the same side as the ground. So sometimes it's the ground is all on the other, it's on the other side with the other things. And in this particular case, it's not, but this is the one that's going to be by itself. So on the opposite side of your black terminal and your usually like a brass colored or a silver colored terminal, brass colored, I believe. And then, you've got just your red wire coming back, and then that's it. And so you've got power on the black here that's actually going to come up to the light, and then you're done. So on the other one, the only thing getting jumpered together, bundled together, if you will, is your ground. So you've got ground coming in, and you're going to need one ground to go to this switch and one ground to go to the next switch. And then you got to connect that in up to the light. Your first wire, your neutral's just going to basically get, I guess technically this is jumpered here, because so I should have drawn that. So jumpered here, and then it's coming over through a wire to this switch. Black is going to connect in to the black coated terminal. You're going to have black also on the one that's by itself. It's going to come over in the wire that's between the two switches, and it's going to connect in the same position on the other side to the wire it's by itself. And then your red wire will connect in next to the black wire. So on that same side to the same place on the other switch. And you'll notice the neutral just bypasses. So it's actually jumpered here, from the wire coming in, providing the power to the 12-3. And then once they leave this switch, actually it's jumpered here as well. So jumpered and jumpered, never mind. But then up to the light switch, and it's that's kind of standard. And of course there is another condition where you can bring the power in at the light, and a lot of older homes I gathered have that style of light being the power source for the switches, and there is a way to wire that. However, in I believe in my state, and I know in other states, that is either frowned upon or outright banned. So when you're wiring new, you want to bring power to switches, not to lights. It's going to make everything a whole lot easier and more consistent, and there's only very occasionally a reason why you would want to or need to bring power to the lights. All right, so I fixed the neutral, now showing that you have to connect in the 3 different wire segments. I hope you all have a great rest of your day. Hope you enjoyed this video, and we'll see you next time.